The following presentation is designed exclusively for educational and entertainment purposes and does not constitute professional automotive, financial, career, legal, or investment advice. The automotive repair industry is currently undergoing a rapid and unprecedented technological transformation. While we will thoroughly examine historical trends, current market data, and potential outcomes regarding this transition, no information presented in this broadcast should be taken as a guarantee of future industry behavior, personal financial success, business profitability, or specific vehicle repair outcomes. The case studies, technological assessments, and economic statistics discussed reflect the landscape of the United States automotive sector at the time of production and are subject to continuous change. Viewers, whether they are everyday vehicle owners, industry professionals, independent shop owners, or technology investors, are strongly advised to conduct their own independent due diligence. It is highly recommended to consult with certified automotive engineers, qualified financial advisors, or legal experts, particularly regarding the rapidly evolving right to repair legislation, before making any significant decisions based on the content of this deep dive. Modern vehicles are incredibly complex, often utilizing high-voltage electrical systems and intricate software networks. Improper maintenance, diagnostics, or physical intervention can lead to severe physical injury, catastrophic financial loss, or property damage. Always proceed with your own thorough risk assessment and prioritize safety above all else. Imagine a highly skilled, third-generation mechanic operating a trusted independent shop in the American Midwest. For decades, this shop has thrived on a foundation of mechanical mastery, diagnosing engine misfires by ear, rebuilding transmissions by hand, and relying on a deep, intuitive understanding of combustion, friction, and fluid dynamics. Now, imagine a customer rolling into that exact same bay with a 2024 model year vehicle, displaying a generic malfunction warning on a completely digital dashboard. The mechanic plugs in a $10,000 diagnostic scanner, a tool that has been the lifeblood of the shop for the last 10 years, only to be met with a cold, unforgiving digital firewall. The screen reads, "Access denied. Proprietary manufacturer software required." In an instant, generations of mechanical expertise are rendered completely powerless by a few lines of encrypted code. The mechanic legally and technically cannot interface with the vehicle, and the customer is forced to tow their car to a certified dealership, paying exorbitant fees for what used to be a standard, routine procedure. This is not a hypothetical scenario from a distant, dystopian future. This is the harsh, unvarnished reality happening in thousands of service bays across the United States at this very moment. We are currently witnessing the largest, fastest, and most ruthless technological wealth transfer in the history of the American automotive industry. To put the sheer scale of this revolution into perspective, consider the technological leap we have taken. In 1996, the government mandated the onboard diagnostics 2 system, commonly known as OBD2. It was a standardized port that allowed anyone with a basic code reader to understand why their check engine light was illuminated. It democratized auto repair and fueled a massive boom in the independent repair market. Fast forward to today, and a modern premium pickup truck rolling off an American assembly line contains upward of 150 million lines of software code. To give that number its proper weight, that is significantly more code than is required to operate a Boeing 787 Dreamliner, the Space Shuttle, or a modern F-35 fighter jet. Your car is no longer a mechanical object that happens to contain computers. It is a highly advanced, rolling supercomputer that happens to have wheels. The shocking truth that the automotive industry rarely advertises is that the traditional neighborhood grease monkey is functionally obsolete. The individual diagnosing your vehicle tomorrow will not rely primarily on wrenches, sockets, or physical intuition. They will rely on encrypted tablets, secure cloud-based manufacturer networks, cybersecurity protocols, and artificial intelligence diagnostic trees. But there is a much darker, highly secretive side to this evolution. A massive multi-billion-dollar battle is currently being waged behind closed doors, in state legislatures, and inside the engineering departments of the world's largest automakers. Manufacturers are increasingly utilizing cybersecurity legislation and advanced software encryption to effectively create a monopoly on vehicle repair. They are actively attempting to become the sole gatekeepers of the data generated by the car you own. If they are successful in maintaining this digital lockout, historical trends suggest that the average cost of vehicle ownership and routine maintenance in America will skyrocket to levels that will fundamentally reshape middle-class transportation budgets. However, If independent technicians, software engineers, and aggressive shop owners figure out how to bridge this staggering technological gap, there is an unprecedented financial opportunity for those willing to adapt to the new paradigm. By the end of this exhaustive masterclass, you will discover the exact proprietary technologies that automakers are fighting relentlessly to keep out of independent hands, the legislative loopholes currently being exploited, and why intimately understanding this silent war could potentially save you thousands of dollars the next time your digital dashboard lights up. The core problem this analysis will solve for the American audience today is the paralyzing asymmetry of information that currently exists between the driver, the independent repair shop, and the corporate automaker. Whether you are a daily commuter relying on your vehicle to maintain your livelihood, an aspiring automotive technician staring down a radically shifting career path, or a seasoned shop owner trying to prevent bankruptcy in the face of insurmountable technological overhead, you are currently operating in the dark. We are going to completely illuminate this complex landscape. We will break down, step by step, the devastating financial impact of advanced driver assistance systems, known as ADAS. We will explore why a minor fender bender that used to cost $500 to physically repair now routinely triggers a $5,000 insurance claim due to the mandatory, hours-long laser calibration of radar, LiDAR, and ultrasonic sensors embedded invisibly within your bumpers and windshields. If these sensors are off by a fraction of a millimeter, your vehicle's automated emergency braking system could trigger maliciously on a clear highway, causing the exact type of catastrophic collision it was designed to prevent. The liability has shifted entirely from the driver's reaction time to the technician's software calibration accuracy. Furthermore, we will dissect the realities of telematics and over-the-air updates. Right now, modern vehicles are constantly transmitting gigabytes of heavily encrypted performance data over cellular networks directly back to manufacturer headquarters, entirely bypassing the dashboard and the driver. Automakers are essentially diagnosing component degradation in real time, often anticipating a mechanical failure days before the driver experiences a symptom. We will examine the profound economic implications of a manufacturer directly contacting a vehicle owner through their dashboard infotainment screen, prompting them to schedule an exclusive service appointment at a dealership, thereby entirely cutting the independent auto repair sector out of the economic loop before the vehicle even breaks down. Finally, we will navigate the incredibly volatile transition to high-voltage electric vehicle architecture. The shift from internal combustion engines to EV platforms is not merely a change in the fuel source. It is a complete teardown of the automotive service infrastructure. We will analyze the severe logistical nightmares surrounding thermal runaway management, the exorbitant costs of specialized safety equipment required just to touch a battery management system, and the critical shortage of high-voltage certified technicians in the United States workforce. This masterclass will strip away the marketing jargon and the corporate obfuscation to provide you with a granular, deeply researched, and strategically vital understanding of how software, sensors, and silicon are fundamentally rewriting the rules of the American road. You will learn exactly how to interpret the digital demands of your vehicle, how to identify repair facilities that have genuinely invested in the future, and how to protect your financial assets in an era where your car's most expensive component is no longer the transmission, but the source code running it. To understand exactly how this source code is weaponized against the American consumer in the year 2026, we must look at a rapidly expanding industry practice known as component serialization, historically referred to in the tech world as parts pairing. Imagine a driver named David living in Columbus, Ohio. David drives a perfectly well-maintained 2024 model year crossover utility vehicle. One afternoon, he accidentally backs into a mailbox, cracking his passenger side taillight assembly. 10 years ago, the solution would be simple and economical. David would visit his local automotive salvage yard, purchase an intact original equipment manufacturer taillight from a wrecked donor vehicle of the same make and model for $50, take it home, unscrew 3 bolts, plug in the wire harness, and the problem would be solved. Today, David follows that exact same logical procedure, physically installing the salvaged taillight with perfect mechanical precision. He turns the ignition key, shifts into reverse, and immediately his dashboard erupts in flashing error codes. The digital display warns of a critical safety system failure, and the vehicle refuses to shift out of park. The taillight itself is mechanically flawless, but David has just collided head first with the invisible wall of component serialization. The microchips embedded within that salvaged taillight assembly are permanently digitally married to the vehicle identification number of the original donor car. When David plugged the wiring harness into his vehicle, his central computer network, known as the Controller Area Network Bus, sent a digital handshake request to the newly installed light. The light responded with the incorrect cryptographic signature. Because the serial numbers do not perfectly match the encrypted database stored within the main engine control module, the vehicle software intentionally disables the component and places the entire vehicle into a restricted limp mode. This is not a malfunction. It is a deliberately engineered feature. David is now physically stranded in his own driveway by lines of code. He is forced to hire a tow truck to transport his technically functional vehicle to a certified dealership. Once there, the dealership informs him that their corporate policy prohibits them from flashing or reprogramming salvaged electronic parts. They mandate that David purchase a brand new, factory-fresh taillight assembly for $800, plus an additional $300 in labor just to connect a proprietary tablet to his dashboard port and authorize the new serial number on the manufacturer's secure cloud server. This historical trend of locking physical parts behind digital firewalls is systematically destroying the used parts market and effectively criminalizing the concept of the independent, do-it-yourself mechanic. This aggressive shift from mechanical repair to software authorization extends far beyond simple lighting fixtures and deep into the critical safety infrastructure of modern American transportation. Consider a case study involving Sarah, a commuter in Austin, Texas, who experiences a minor 5-mile-per-hour collision in a grocery store parking lot. Her front bumper sustains a slight cosmetic indentation. Historically, an independent body shop would heat the plastic, pull the dent, apply touch-up paint, and return the vehicle for a few $100s. However, Sarah drives a vehicle equipped with advanced driver assistance systems. Hidden directly behind the thin plastic of her bumper cover is a highly sensitive millimeter wave radar unit responsible for the automatic emergency braking and adaptive cruise control features. The minor parking lot bump did not break the radar, but it pushed the mounting bracket backwards by precisely 2 millimeters. When Sarah attempts to drive home, her vehicle software detects a slight discrepancy in the radar feedback loop and disables all advanced safety features. When she takes the vehicle to an independent repair facility, she is handed a repair estimate that shocks her. The physical plastic repair is only $300, but the mandatory digital calibration of the radar system brings the total bill to over $3,000. The independent technician explains the staggering complexity of the required procedure. To realign that radar unit, the shop cannot simply eyeball the placement. They must pull Sarah's vehicle into a massive, perfectly leveled indoor bay with zero reflective surfaces. They must attach highly precise laser measuring tools to the wheel hubs to find the exact geometric centerline of the chassis. They must then arrange massive, specifically patterned target boards at exact distances and angles from the front of the vehicle, sometimes requiring 50 feet of completely clear floor space. Finally, they must use a specialized diagnostic computer, which costs the shop tens of thousands of dollars in annual licensing fees, to instruct the vehicle to look at the targets and rewrite its internal geometry. The potential outcomes of skipping this exhaustive calibration process are legally and physically catastrophic. If the independent technician fails to calibrate the radar properly, the sensor might believe the vehicle is traveling straight when the internal geometry is actually pointed slightly into the oncoming lane. At highway speeds, the vehicle computer might register a safely passing semi-truck as an imminent head-on collision and violently trigger the automatic emergency braking system, bringing the vehicle to a sudden, unexpected halt in the middle of a busy interstate. The liability for that resulting multi-car pileup would fall entirely on the independent shop that failed to execute the software calibration. Because of this massive legal risk and the exorbitant cost of the calibration equipment, thousands of neighborhood body shops across the United States are currently refusing to touch modern vehicles, forcing consumers like Sarah to wait months for appointments at massively backlogged, corporately owned collision centers. This rapid consolidation of repair capability is creating a deeply concerning economic bottleneck in the American automotive ecosystem. We are witnessing a systemic starvation of the independent aftermarket. The barrier to entry for a young, aspiring automotive technician in 2026 is no longer mastering the physics of internal combustion. It is affording the crushing debt of commercial software subscriptions, cybersecurity gateway access fees, and proprietary dealership scan tools. Automakers argue that these encrypted firewalls are absolutely necessary to protect vehicles from malicious remote hacking and to ensure that complex high-voltage electric systems are not mishandled by untrained personnel. However, independent repair advocates and consumer rights groups argue that these cybersecurity measures are conveniently designed to function as impenetrable anti-competitive monopolies, forcing the consumer to pay premium dealership prices for the entire lifespan of the vehicle. The battleground has shifted from the garage to the courtroom, with state legislatures actively debating right-to-repair bills designed to force automakers to share these cryptographic keys with independent mechanics. But while the legal system slowly grinds through these massive antitrust arguments, the automakers are quietly rolling out an even more sophisticated technology that threatens to bypass the repair shop entirely. They are utilizing the cellular networks blanketing the country to communicate directly with the microchips inside your driveway, diagnosing internal component wear, scheduling premium service appointments, and potentially restricting engine performance without ever requiring you to turn a wrench or plug in a scanner. The true battle for the future of your vehicle is not happening under the hood. It is happening invisibly through the air, and the data being transmitted while you sleep will fundamentally change everything you thought you knew about vehicle ownership. This invisible stream of information is heavily reliant on a technology called automotive telematics, a system that transforms your daily commute into a massive, continuous data harvesting operation. To comprehend the sheer volume of this surveillance, consider that a fully connected vehicle rolling off the assembly line in the year 2026 generates roughly 25 gigabytes of data every single hour it is in operation. This is not simply GPS location tracking or satellite radio preferences. The vehicle is meticulously logging the exact angle of your steering wheel during cornering, the microsecond variations in your braking pressure, the ambient temperature of your transmission fluid, and the precise electrical resistance across hundreds of individual sensor circuits. Every time the vehicle is parked and connected to a cellular network or a home wireless internet connection, it silently uploads this heavily encrypted treasure trove of operational data directly to the manufacturer headquarters. Historical trends indicate that whoever controls this massive repository of vehicle data ultimately controls the entire automotive service economy. Let us examine a highly probable scenario involving a commuter named Michael, who lives in the suburbs of Chicago. Michael relies on his 2025 luxury hybrid sedan for a grueling 60-mile daily commute. Historically, if Michael experienced a failing fuel injector, he would drive until the engine began to physically misfire. The check engine light would illuminate on his dashboard, and he would limp the vehicle to his trusted local mechanic for a diagnostic test and repair. The independent mechanic would earn the revenue for both the diagnostic labor and the part replacement. However, in the current telematics paradigm, the narrative changes entirely. While Michael is driving on the interstate, the internal sensors detect a microscopic voltage anomaly in the number 3 fuel injector circuit. The vehicle is not misfiring yet, and Michael feels absolutely nothing wrong with the engine performance. That night, while Michael is asleep, his vehicle uploads the voltage irregularity to a cloud-based artificial intelligence server operated by the automaker. The manufacturer server processes the data, compares it against millions of other vehicles of the same make and model, and determines that this specific voltage signature indicates a 90% probability of complete injector failure within the next 400 miles. The next morning, when Michael starts his car, a high-definition video message takes over his entire infotainment screen. The message bypasses the generic check engine light entirely. Instead, it explicitly warns Michael that a critical fuel delivery component is degrading and immediately offers to route the vehicle navigation system to the nearest authorized corporate dealership. The screen even displays available appointment times for that exact afternoon and provides a preliminary estimate for the repair. The manufacturer has effectively diagnosed the vehicle, sourced the required parts, and scheduled the service appointment before the physical failure ever occurred, and before Michael even realized there was a problem. The independent repair shop never stood a chance. They are completely locked out of this predictive algorithmic maintenance funnel. By the time the vehicle requires a physical wrench, the financial transaction has already been secured by the corporate dealership network. This technological chokehold is further tightened by the aggressive implementation of over-the-air software updates. We are accustomed to our smartphones updating their operating systems overnight, bringing new features and security patches. Automakers have successfully adopted this exact same model for 2-ton machines traveling at highway speeds. While over-the-air updates offer the convenience of fixing minor software glitches without a physical trip to the service bay, they also introduce a terrifying level of remote control over the vehicle hardware. Manufacturers now possess the unmitigated capability to remotely alter the fundamental performance characteristics of your vehicle after you have already purchased it. Consider a case study regarding a driver named Jessica living in Miami. In 2026, Jessica purchases a pre-owned electric vehicle from a private seller. The vehicle was originally manufactured with the premium hardware package, meaning the physical factory-installed seats contain electronic heating elements, and the electric motors are physically capable of generating 400 horsepower. The previous owner paid a premium to utilize these features. However, upon transferring the digital vehicle title into her name, Jessica discovers that her heated seats no longer function, and the vehicle acceleration has been dramatically reduced to a maximum of 250 horsepower. The physical hardware is still perfectly intact inside the car, but the manufacturer has utilized an over-the-air cellular signal to digitally lock the features. When Jessica contacts the manufacturer, she is informed that the original software licenses were non-transferable. To activate the heating elements physically present beneath her legs, she must pay a $15 monthly subscription fee. To unlock the full horsepower of the electric motors, she must pay a one-time digital upgrade fee of $2,000. When Jessica takes her vehicle to an independent repair facility to see if they can physically bypass the software block and turn on her heated seats, the mechanic is forced to refuse the job. Attempting to circumvent these digital locks places the independent mechanic in direct violation of the Digital Millennium Copyright Act. What was once considered a simple automotive repair is now legally classified as federal copyright infringement and software piracy. The independent mechanic faces severe financial penalties and potential jail time for simply attempting to bridge a circuit to provide power to a seat heater. The automotive repair industry is rapidly shifting from a profession of mechanical restoration into a highly restricted realm of digital rights management, where the manufacturer retains ultimate ownership and control over the functionality of the vehicle, regardless of who holds the physical paper title. The barrier to entry for independent shops is no longer just purchasing expensive tools. It is employing software engineers capable of navigating complex, legally perilous cryptographic firewalls just to perform basic physical repairs. But if the weaponization of vehicle data, predictive maintenance, and software subscriptions seems like an insurmountable hurdle for the independent automotive technician, it pales in comparison to the looming physical and logistical nightmare currently rolling off the assembly lines. The internal combustion engine, with its millions of moving mechanical parts, is slowly being phased out in favor of something vastly more dangerous and fundamentally alien to the traditional repair bay. We must now turn our attention to the complete teardown of the physical automotive service infrastructure, because when a vehicle is no longer powered by highly combustible liquid fuel, but instead by 600 pounds of densely packed lithium-ion cells capable of generating 800 volts of lethal direct current, the entire concept of a neighborhood repair shop is pushed to the absolute brink of extinction. To comprehend the sheer magnitude of this physical transition, we must first abandon everything we know about traditional automotive diagnostics. For over a century, the American mechanic has relied heavily on sensory input. A skilled technician can diagnose a failing water pump by the high-pitched squeal of a bearing, identify a rich fuel mixture by the sharp smell of unburned hydrocarbons exiting the tailpipe, or feel the specific vibration of a misfiring cylinder through the steering column. An electric vehicle provides absolutely none of these sensory warnings. An 800-volt direct current electrical system does not leak visible fluid, it does not rattle, and it does not smell. It is completely silent, and if handled incorrectly, it is instantly lethal. The transition from internal combustion to high-voltage electric architecture is not a lateral move for a repair shop. It is an entirely different scientific discipline, requiring a complete reimagining of workplace safety, liability, and specialized equipment. Consider the reality of a seasoned independent shop owner named Marcus, operating a highly successful 3-bay garage in Denver, Colorado, in the year 2026. Marcus recognizes the historical trends shifting toward electric vehicles and decides he must upgrade his facility to service this new generation of automobiles. When Marcus begins pricing the necessary equipment to safely open just one single electric vehicle service bay, the financial reality is staggering. He cannot use his standard steel wrenches or sockets. He must purchase entirely new sets of strictly rated, fully insulated fiberglass hand tools. His technicians cannot simply lean over a fender in a cotton uniform. They must be outfitted in Class 0 high-voltage arc flash suits, complete with specialized dielectric rubber gloves that must be rigorously pressure-tested for microscopic pinholes every single time they are worn. Because an electric vehicle battery pack is not easily accessible under a hood, but is instead bolted to the entire floor pan of the vehicle, Marcus cannot use a standard 2-post hydraulic lift to remove it. He must invest tens of thousands of dollars in a specialized, precision-controlled scissor lift table capable of safely supporting and perfectly aligning a lithium-ion battery pack that weighs over 3,000 pounds. But the equipment costs are merely the initial financial hurdle. The true existential threat to independent shops like the one Marcus owns lies in the catastrophic liability associated with electric vehicle chemistry. If a traditional mechanic makes an error and accidentally spills gasoline, they clean it up, ventilate the bay, and move on. If an electric vehicle technician makes a microscopic error during a high-voltage procedure, drops a non-insulated tool across a live bus bar, or accidentally breaches the internal cooling channel of a battery module, the potential outcomes are catastrophic. The lithium-ion cells can enter a state known as thermal runaway. This is not a standard fire that can be extinguished with a shop fire extinguisher. Thermal runaway is a self-sustaining, cascading chemical chain reaction that generates its own oxygen as it burns, reaching temperatures exceeding 5,000 degrees Fahrenheit in a matter of seconds. Water does not stop it. It only cools the surrounding area while the chemical fire rages inside the sealed metallic casing. If a thermal runaway event occurs inside Marcus's shop, the entire commercial building will likely burn to the foundation before the fire department can contain it. Because of this unprecedented risk, commercial insurance providers are now mandating that any independent shop servicing electric vehicles must construct dedicated, blast-proof quarantine bays with specialized ventilation and thermal imaging monitoring systems, effectively pricing out 95% of independent neighborhood garages in America. This drastic consolidation of repair infrastructure is directly impacting the American consumer in deeply painful ways. Imagine a driver named Emily living in Atlanta. While driving her 2025 electric crossover utility vehicle on the interstate, she runs over a piece of metal road debris. The debris strikes the thick titanium belly pan protecting her battery pack. The vehicle continues to drive perfectly, but a high-voltage system warning light illuminates on her dashboard. Because independent shops cannot safely handle the vehicle or access the encrypted battery management software, Emily is forced to take her car to the manufacturer dealership. The dealership technicians hoist the vehicle and observe a superficial half-inch dent in the external metal casing of the battery pack. The internal lithium cells are completely untouched and functioning perfectly. However, the manufacturer engineering protocols strictly dictate that any physical deformation of the battery casing structurally compromises the integrity of the entire unit. The dealership informs Emily that they are not authorized to open the pack, inspect the modules, or replace the damaged metal cover. The only authorized repair procedure is a complete, total replacement of the entire 3,000-pound battery pack. The repair estimate handed to Emily is $22,000. Her vehicle, which she purchased new just 1 year prior, is functionally mechanically totaled by a minor scrape on the highway. This is happening because automakers are increasingly utilizing structural battery pack designs, where the individual battery cells are heavily glued directly into the chassis of the vehicle using structural polyurethane adhesives. They are explicitly designing these components to be unrepairable, non-modular, and completely sealed. When a single internal cell degrades, or a minor external scratch occurs, the consumer is forced to absorb the cost of replacing the single most expensive component in the entire vehicle. This is compounded by a massive nationwide labor crisis. The United States educational system and traditional vocational schools are simply not producing certified high-voltage automotive technicians fast enough to meet the demand. The few highly trained engineers capable of safely navigating these lethal electrical systems and cracking the complex software codes are immediately absorbed by corporate dealership networks offering massive signing bonuses, leaving the independent sector entirely starved of talent. We are transitioning into an era where the vehicle you own is a black box of proprietary code and lethal chemistry, designed specifically to push you back into the corporate ecosystem for every single maintenance need. But the automakers and the lack of trained technicians are only two pieces of this massive economic puzzle. The true cost of this technological revolution is quietly destroying another major pillar of the American economy, and the next time you renew your auto insurance policy, you are going to pay the exact price of this invisible war. The automotive insurance industry in the United States is currently experiencing a catastrophic crisis of profitability, and the burden of this crisis is being systematically offloaded directly onto the monthly premiums of the American driver. To understand this dynamic, we must dissect the historical trends of automotive claims adjusting. A decade ago, an insurance adjuster would evaluate a front-end collision by looking at bent steel, crumpled aluminum, and shattered plastic. They would calculate the cost of replacement panels, a few hours of labor for a body shop technician, and a fresh coat of paint. The average severity of a collision claim was highly predictable and relatively low. Today, in the year 2026, that exact same low-speed impact is no longer a matter of simple metallurgy. It is a mass casualty event for highly sensitive, incredibly expensive microelectronics. Consider a case study involving a driver named Robert who resides in Detroit, Michigan. Robert drives a late-model 2025 electric sport utility vehicle. While navigating a congested parking garage, he misjudges a concrete pillar and scrapes the front right corner of his vehicle at a speed of roughly 3 miles per hour. The visible damage is seemingly superficial. The plastic bumper cover is deeply scratched, and the passenger side headlight assembly is cracked. In a traditional internal combustion vehicle from the year 2010, this would represent a standard insurance claim of perhaps $1,200. Robert assumes his comprehensive coverage will handle it with a minimal deductible. However, when the insurance adjuster arrives to evaluate the 2025 electric sport utility vehicle, the reality of modern automotive engineering fundamentally alters the financial equation. The adjuster notes that the cracked headlight is not a simple halogen bulb sitting inside a plastic housing. It is a highly advanced matrix LED lighting system, containing thousands of individually controlled micro-light-emitting diodes designed to actively map the road and dim specific sectors to avoid blinding oncoming traffic. The replacement cost for this single headlight assembly is an astonishing $3,800. Furthermore, the scratched bumper cover houses a short-range radar module, 2 ultrasonic parking sensors, and a peripheral vision camera tied into the autonomous driving suite. Even though the sensors might still function, manufacturer repair procedures dictate that any impact in that quadrant requires full replacement of the wiring harness to guarantee no microfractures occurred in the data lines. Finally, the physical repair mandates a complete recalibration of the entire front-facing sensor array, a process requiring specialized laser alignment tools and proprietary software access. The final repair estimate for a 3-mile-per-hour parking garage scrape balloons to over $14,000. Faced with these astronomical repair costs, major national insurance carriers are fundamentally altering their business models. Historical trends show a massive spike in the frequency of total loss declarations. Insurance companies are realizing that the potential outcomes of attempting a complex, highly technical repair on a modern vehicle carry far too much financial and legal risk. If they authorize the $14,000 repair, and a third-party calibration center makes a microscopic error in aligning the radar, the insurance company could be held liable if Robert later experiences a malfunction that leads to a catastrophic highway collision. It is often mathematically safer and cheaper for the insurance company to simply declare the perfectly drivable vehicle a total salvage loss, pay Robert the depreciated cash value, and auction the vehicle to a scrap yard. This hyperinflated claims environment is driving up the baseline cost of insurance for every single driver on the road, regardless of their personal driving record. But the technological extraction of your wealth does not stop at the repair shop or the claims adjuster. It extends deep into the highly unregulated world of automotive data brokering. Imagine a driver named Amanda in Phoenix, Arizona, in 2026. Amanda has a pristine driving record. She has never filed an insurance claim, she has no speeding tickets, and she meticulously maintains her vehicle. Yet, when her auto insurance policy comes up for its 6-month renewal, she is shocked to discover that her premium has increased by 45%. She calls her insurance agent, expecting a clerical error, only to be informed that her rate increase is based on a newly generated driving behavior risk profile. Without Amanda fully understanding the depth of the user agreements she clicked through on her vehicle infotainment screen, her car has been acting as an undercover informant for the insurance industry. Every time she drives, her vehicle's cellular modem transmits a highly detailed telematics package to third-party data brokers. These companies aggregate billions of data points from connected cars across the country. They log every instance Amanda brakes hard, every time she accelerates rapidly to merge onto a busy freeway, and every time she drives past midnight. What the algorithmic risk model completely fails to contextualize is the human reality behind the data. The algorithm recorded a severe hard braking event on a Tuesday afternoon and penalized her risk score. What the algorithm did not record was that Amanda slammed on her brakes to avoid striking a stray dog that had darted into the intersection. The algorithm recorded rapid acceleration on a Thursday morning. It did not record that Amanda was aggressively maneuvering to avoid a distracted driver drifting into her lane. The insurance industry is increasingly relying on these stripped-down, contextless data sets to dynamically price consumer premiums. Automakers are actively profiting from this surveillance by selling the telemetry data generated by your daily commute to these massive data clearinghouses. The consumer is forced to purchase a highly expensive, technologically advanced vehicle, pay exorbitant repair costs when the proprietary sensors fail, and then suffer punishing insurance premium hikes based on the data harvested from those very same sensors. The American driver is effectively trapped in a closed loop of continuous financial extraction, where the vehicle is no longer a tool of personal freedom, but a mobilized data harvesting platform designed to feed multiple corporate revenue streams simultaneously. This aggressive corporate overreach, combined with the impenetrable digital locks placed on physical parts and the astronomical cost of specialized electric vehicle infrastructure, has created a massive, highly motivated underclass of disenfranchised mechanics, software engineers, and angry vehicle owners. When the legitimate pathways to ownership and repair are systematically dismantled by corporate monopolies, history dictates that human ingenuity will immediately seek alternative, often illicit, solutions. A shadow economy is rapidly forming in the dark corners of the internet and in unmarked garages across the country. A sophisticated network of digital renegades is actively reverse engineering manufacturer source code, bypassing encrypted gateways, and developing illegal hardware modifications just to keep American cars on the road. The true battle line for the right to repair is no longer in the courtroom. It has moved to the automotive black market, and the tactics being deployed by these underground mechanics are as brilliant as they are legally perilous. Welcome to the era of automotive jailbreaking, a rapidly expanding digital frontier where the line between a routine mechanical repair and federal copyright infringement has been completely erased. To truly understand the scale of this underground economy in the year 2026, we must examine the sheer desperation driving everyday Americans to commit digital felonies just to get to work. We are witnessing the emergence of a highly sophisticated, decentralized network of rogue software engineers, overseas code breakers, and local technicians who are actively circumventing the multi-billion-dollar digital firewalls erected by the world's largest automakers. They are not doing this for the thrill of the hack. They are doing it because the traditional avenues of vehicle ownership and maintenance have become financially inaccessible for the working class. Consider a highly illustrative case study involving an independent agricultural contractor named Kevin, operating a massive cattle ranch in the remote plains of West Texas. Kevin relies entirely on a 2025 heavy-duty diesel pickup truck to haul livestock, transport heavy equipment, and maintain his livelihood. This truck is not a luxury item. It is a critical piece of commercial infrastructure. One morning, while navigating a desolate stretch of Highway 200 miles from the nearest authorized dealership, Kevin's dashboard illuminates with a critical emissions system error. A tiny, heavily encrypted sensor monitoring the diesel exhaust fluid has failed. Historically, a faulty sensor might cause the engine to run slightly less efficiently, but the vehicle would still physically operate. However, in 2026, modern software protocols dictate a much more aggressive response. The central engine control module detects the sensor failure and immediately triggers a mandated countdown timer on the digital display. The truck informs Kevin that he has exactly 50 miles to reach a certified service center before the software permanently derates the engine, effectively restricting his towing capacity to 0 and limiting his top speed to 10 miles per hour. This is a deliberate software-induced limp mode designed to force compliance. Kevin is faced with a catastrophic financial calculation. Towing a massive, heavily loaded truck 200 miles to a dealership will cost thousands of dollars. The dealership will then charge him premium labor rates to replace a sensor that physically costs $50, simply because they are the only entity holding the cryptographic keys required to tell the truck's computer that the new sensor is legitimate. Unable to absorb this devastating loss of time and capital, Kevin turns to the automotive shadow economy. Utilizing encrypted online forums, Kevin purchases a black market software package often referred to as a delete tune or a security gateway bypass. This is highly illegal, uncertified software typically developed by reverse engineering groups in Eastern Europe who have successfully cracked the manufacturer's proprietary code. Kevin downloads this illicit firmware onto a ruggedized, modified tablet and plugs it directly into the onboard diagnostics port beneath his steering wheel. He effectively executes a brute force hack on his own property. The black market software attacks the digital handshake protocols within the truck's local network, completely rewriting the operating system of the engine control module. It forcefully commands the computer to permanently ignore the physical presence of the diesel exhaust fluid sensor and disables the software-induced limp mode. Within 20 minutes, the digital warnings vanish, full engine power is restored, and Kevin is back on the road. The potential outcomes of this action, however, are immense. By flashing this unauthorized software, Kevin has instantly voided his entire powertrain warranty. He has blatantly violated Federal Environmental Protection Agency emissions regulations, and he has potentially exposed himself to a crushing lawsuit under the Digital Millennium Copyright Act for circumventing a technological protection measure. Yet, for thousands of rural Americans and independent contractors in 2026, the immediate economic survival of their business far outweighs the abstract threat of a corporate lawsuit. This underground rebellion is not limited to remote highways and diesel trucks. It is thriving in the heart of major American cities, fundamentally altering how independent neighborhood garages operate. Imagine an experienced independent mechanic named Luis, running a highly respected, 3-bay automotive repair shop in the suburbs of Chicago. In order to legally diagnose and repair the highly complex computer networks of modern vehicles, automakers demand that independent shops like the one Luis owns pay exorbitant annual licensing fees for official, proprietary diagnostic software. These subscriptions can easily exceed $20,000 a year per manufacturer. For a small business servicing 10 different brands of vehicles, maintaining legal, authorized access to every software ecosystem is mathematically impossible. The corporate software toll booth is actively bankrupting the independent sector. To survive, independent shops are increasingly relying on unauthorized clone tools. These are sophisticated pieces of counterfeit hardware, manufactured overseas, designed to flawlessly mimic the authorized diagnostic tablets used by corporate dealerships. These clone tools are loaded with pirated, cracked versions of the manufacturer's official software, allowing mechanics like Luis to bypass the component serialization locks, calibrate advanced driver assistance systems, and clear deep-level security codes without paying the massive corporate licensing fees. The automotive industry is fully aware of this widespread piracy and is fighting back with aggressive, militarized software tactics. Automakers are now utilizing the constant cellular connection of modern vehicles to hunt down these unauthorized diagnostic tools in real time. If a mechanic plugs a pirated clone tool into a 2026 vehicle, the car immediately detects the unauthorized digital signature. The vehicle then sends a silent alert back to the manufacturer's cloud server. In a fraction of a second, the manufacturer can beam a targeted over-the-air update directly down to the vehicle, instructing the car's gateway module to permanently fry the internal circuitry of the unauthorized tool plugged into the dashboard, instantly turning a $3,000 piece of black market hardware into a useless brick of plastic. This is an invisible, relentless cyber war happening inside millions of service bays. A continuous cat-and-mouse game between corporate software engineers trying to lock down the vehicle network and rogue mechanics fighting desperately to keep the right to repair alive. However, this relentless hacking and bypassing of digital security systems introduces a terrifying new vulnerability to the American public. When vehicle owners and independent mechanics intentionally open backdoors in a car's operating system to bypass a broken sensor or install a salvaged part, they are actively dismantling the cybersecurity infrastructure designed to protect the vehicle from malicious actors. Historical trends in cybersecurity clearly demonstrate that any backdoor created for convenience or repair is inevitably discovered and exploited by hostile entities. If a rural farmer can download a software patch to bypass an engine immobilizer, a sophisticated hacking syndicate can utilize that exact same vulnerability to remotely intercept vehicle telematics, track the real-time location of thousands of drivers, or potentially execute a devastating fleet-wide ransomware attack, locking millions of Americans out of their own cars until a digital ransom is paid. The desperate fight to maintain physical ownership of our vehicles is inadvertently creating one of the largest national security blind spots of the modern era. But the automakers are not simply relying on lawsuits and software patches to win this war. They are preparing to deploy a technological architecture so profoundly intrusive and financially extractive that it fundamentally redefines the very concept of private property, transforming the physical machine sitting in your driveway into a temporary, heavily monitored corporate lease. This transition represents the death of traditional automotive ownership and the birth of what industry insiders refer to as hardware as a service. To understand how aggressively this model is being deployed in the year 2026, we must look at the financial engineering occurring in corporate boardrooms and how it directly impacts the physical manufacturing of the vehicle itself. Historically, automakers operated on a very simple linear business model. They manufactured a highly complex machine, sold it to a consumer for a lump sum, and realized their profit immediately. The manufacturer only made money again if the consumer returned to the dealership for maintenance or parts. However, historical trends in the technology sector have proven that Wall Street values recurring subscription revenue infinitely higher than one-time hardware sales. Automakers have watched software companies achieve trillion-dollar valuations simply by forcing their users into monthly payment ecosystems, and they have decided to replicate that exact model using the 2-ton vehicle parked in your garage. To execute this, manufacturers have fundamentally changed how cars are assembled. It is incredibly expensive and logistically complicated to maintain multiple different assembly line processes for different vehicle trim levels. Therefore, in 2026, many manufacturers have adopted a unified production strategy. They now build every single vehicle with the absolute maximum level of physical hardware installed. Every car rolling off the line contains the physical radar modules for adaptive cruise control, the heavy copper wiring and heating elements for heated seats, the mechanical actuators for rear-wheel steering, and the high-capacity battery modules for maximum range. However, when the consumer purchases the base model, they are physically buying all of that hardware, but the manufacturer uses millions of lines of encrypted code to electronically lock those features. The consumer is driving around carrying hundreds of pounds of expensive, dormant hardware that they physically own but are legally prohibited from utilizing, unless they agree to a continuous, unending series of microtransactions. Consider a case study involving a driver named Thomas living in Seattle, Washington. Thomas purchases a brand new 2026 luxury sedan. He opts for the standard package because he cannot afford the $10,000 premium for the advanced technology suite. 6 months later, Thomas decides to take a cross-country road trip and realizes that adaptive cruise control and lane centering would severely reduce his driving fatigue. 10 years ago, adding these features after the factory purchase would be impossible. Today, Thomas simply opens the manufacturer application on his smartphone, navigates to the vehicle upgrade store, and clicks a button. He agrees to a monthly subscription fee of $35. Instantly, an over-the-air cellular signal is beamed down from a corporate satellite directly to the modem embedded in his dashboard. The signal unlocks the digital firewall, and the physical radar sensors hidden inside his front bumper suddenly activate. Thomas is now renting the functionality of a physical component that has been sitting inside his own bumper since the day he drove it off the lot. This microtransaction economy fundamentally alters the definition of private property, but the true devastation of this model is not realized until the vehicle enters the secondary market. We must examine the catastrophic potential outcomes for the used car industry. Imagine a driver named Maria living in Miami, Florida. 3 years after Thomas purchases his sedan, he decides to sell it to Maria through a private transaction. Maria test drives the vehicle and utilizes the adaptive cruise control, the heated steering wheel, and the advanced navigation maps. She pays Thomas a premium price based on the presence of these highly desirable features. They sign the physical paper title, and Maria drives her newly purchased vehicle home. However, the moment Maria registers the vehicle in her name, the manufacturer is notified of the ownership transfer through commercial data brokers. The manufacturer immediately sends a remote signal to the vehicle, executing a complete digital factory reset. When Maria starts the car the next morning, the heated seats no longer function, the adaptive cruise control is disabled, and the navigation screen is blank. The manufacturer dictates that the software subscriptions Thomas paid for were tied to his specific user profile, not to the physical hardware of the vehicle. Maria now owns a heavy deactivated shell. To restore the vehicle to the exact condition it was in when she purchased it 24 hours prior, she is forced to open her own account with the automaker and begin paying hundreds of dollars a month in recurring subscription fees. The manufacturer is essentially double-dipping, forcing a secondary consumer to pay for the activation of hardware that has already been purchased and installed. This process completely hollows out the residual value of used vehicles and traps lower-income buyers in a perpetual cycle of software leasing. But this architecture of absolute connectivity and remote control extends far beyond heated seats and navigation maps. It grants unprecedented, almost terrifying power to lending institutions and corporate finance departments. Let us take the concept of the heavily monitored corporate lease to its logical conclusion. Imagine a driver named David operating as an independent contractor in Atlanta, Georgia. Due to an unexpected medical emergency, David completely depletes his savings and misses 2 consecutive monthly payments on his auto loan. In the past, the bank would be forced to hire a local repossession agency to physically track down the vehicle, a process that could take weeks or months. In 2026, the financial institution simply logs into a secure web portal and links directly to the telematics system of David's vehicle. When David attempts to leave his house for a job interview, he inserts his key, but the engine completely refuses to turn over. The dashboard infotainment screen flashes a stark, unclosable message stating that the vehicle immobilizer has been remotely activated due to account delinquency. Furthermore, the vehicle utilizes its internal GPS to geofence itself, completely disabling the transmission so it cannot be pushed or towed by an unauthorized party. The vehicle has essentially repossessed itself in David's own driveway. The potential outcomes of this immense centralized power are chilling. If a manufacturer or a bank can remotely disable a vehicle for a missed payment, they possess the exact same capability to disable a vehicle based on an expired insurance policy, an unpaid traffic citation, or even a mandated corporate recall. The physical machine you rely on for survival is no longer an independent asset. It is a highly conditional node on a corporate network, subject to instant deactivation at the press of a button hundreds of miles away. As the American consumer realizes they are rapidly losing control of their own property, and as the independent mechanic is systematically starved of the data required to fix these rolling computers, the entire automotive ecosystem is approaching a massive breaking point. The traditional neighborhood garage is being regulated, encrypted, and priced out of existence. But in the highly lucrative world of automotive repair, nature abhors a vacuum. While the local mechanic is forced to close their doors, a new, massive, and incredibly well-funded predator is quietly stepping into the void. Wall Street private equity firms have smelled blood in the water, and they are currently executing a multi-billion-dollar consolidation strategy that will forever eliminate the concept of the independent auto shop. The next time you see a familiar locally owned garage sign being taken down, you need to understand exactly who is buying the property, because the corporate behemoths replacing your local mechanic are operating on a business model that makes the automaker's software subscriptions look like a bargain. Welcome to the era of the private equity roll-up, a ruthless financial strategy that is systematically devouring the American independent auto repair industry in the year 2026. To comprehend the sheer scale of this corporate takeover, we must look past the grease and the wrenches and examine the complex financial engineering occurring behind the scenes. Wall Street investment firms are not interested in building new repair facilities from the ground up. That process takes far too much time and carries too much operational risk. Instead, they are executing massive consolidation campaigns. They deploy vast pools of capital to quietly purchase dozens, sometimes hundreds, of highly profitable, well-respected independent garages within a specific geographic region. The brilliance and the danger of this strategy lie in its complete invisibility to the average American consumer. When a private equity firm purchases your trusted neighborhood garage, they almost never change the sign above the door. They intentionally keep the legacy family name, relying on the decades of localized trust and goodwill that the original owner built within the community. But while the exterior remains comfortingly familiar, the entire internal operating structure is completely gutted, fundamentally transformed from a service-oriented small business into a highly aggressive, data-driven retail machine. Let us examine a highly representative case study involving a veteran mechanic named Arthur, who has operated a highly successful, for-bay independent shop in the suburbs of Philadelphia for over 30 years. Arthur is universally trusted by his community. He is known for talking customers out of unnecessary repairs and keeping aging vehicles safely on the road for minimal cost. However, in 2026, Arthur is staring down the catastrophic financial realities of the modern industry. He is facing the crushing cost of specialized electric vehicle infrastructure, the paralyzing expense of authorized manufacturer software subscriptions, and a severe shortage of qualified technicians capable of diagnosing high-voltage systems. When a corporate acquisition representative approaches Arthur with a massive, multi-million-dollar cash offer to purchase his property and his business outright, the historical trends show that owners like Arthur are overwhelmingly choosing to take the money and retire. The community loses a master diagnostician and an honest broker, and the private equity firm gains another highly lucrative node in their rapidly expanding regional monopoly. The true impact of this silent transition is felt exclusively by the consumer. Imagine a driver named Brenda, who has been bringing her vehicles to Arthur's shop for 15 years. A few months after the unannounced corporate buyout, Brenda schedules an appointment for a routine brake pad replacement on her 2021 commuter sedan. Historically, Arthur would physically inspect the brake system, quote her a fair price for high-quality friction materials, charge her for 1 hour of standard labor, and send her safely on her way for a few $100s. Today, under the new private equity management structure, Brenda's experience is fundamentally different. She is no longer greeted by a mechanic with grease on his hands. She is greeted by a sharply dressed individual known as a service advisor, a role that functions far more like a high-pressure financial broker than an automotive expert. The service advisor does not simply write a ticket for brake pads. Instead, they inform Brenda that corporate policy mandates a complimentary, multi-point digital safety inspection. While this sounds like a generous value add, it is actually a highly sophisticated, psychologically engineered sales tactic. A technician in the back plugs a tablet into Brenda's vehicle, running a proprietary software algorithm designed to flag any component that falls even slightly outside of factory specifications, regardless of whether it represents an actual safety hazard. 10 minutes later, the service advisor presents Brenda with a high-definition digital report on a tablet. The interface is meticulously designed by behavioral psychologists to trigger anxiety and urgency. The screen is filled with bright yellow and glaring red indicators. The algorithm suggests that while her brake pads do need replacing, her brake fluid exhibits a microscopic degradation in boiling point, her cabin air filter shows trace amounts of particulate matter, her fuel injection system requires a comprehensive preventative chemical flush, and her advanced driver assistance sensors demand a full laser recalibration. The routine $300 brake job is instantly inflated into a $1,400 comprehensive safety restoration package. The service advisor is heavily incentivized by an aggressive commission structure to close this massive ticket. Their personal income is directly tied to a metric known as the average repair order. This creates a terrifying conflict of interest where the primary objective of the facility is no longer the mechanical necessity of the vehicle, but the maximum extraction of wealth from the consumer sitting in the waiting room. This financial extraction is further compounded by the aggressive vertical integration of the automotive supply chain. Private equity firms do not merely want to capture the profit margin on the repair labor. They want to completely monopolize the profit margin on the physical parts being installed. Historical trends indicate that as these corporate behemoths grow, they are simultaneously acquiring massive regional auto parts distribution networks. When Brenda finally agrees to the inflated repair bill, the corporate shop does not source the highest quality original equipment manufacturer parts for her vehicle. Instead, corporate policy dictates that the shop must use their own vertically integrated, white-label aftermarket parts, which are often manufactured overseas at a fraction of the cost and built to vastly inferior tolerances. However, the corporate shop bills Brenda at the premium top-tier price point. The private equity firm captures the labor margin, the diagnostic software fee, and a massive, hidden markup on the inferior physical components, all while Brenda believes she is still doing business with the honest, trusted neighborhood shop that Arthur built. This relentless drive for maximum profitability is also devastating the American automotive workforce. The young technicians employed by these corporate chains are no longer being trained as holistic master mechanics capable of deeply understanding the physics and engineering of an automobile. They are being systemically dekilled, trained specifically to act as biological extensions of the diagnostic tablet. If the software algorithm dictates that a sensor module needs to be replaced, the technician simply swaps the module. They are completely insulated from the actual diagnostic reasoning, ensuring that the corporate entity retains all the intellectual property and technical power. The modern corporate mechanic is rapidly being reduced to an interchangeable gig worker, frantically turning wrenches to meet arbitrary corporate efficiency metrics, entirely detached from the craftsmanship that once defined the trade. The American driver is currently trapped in a rapidly shrinking, highly hostile environment. On one side, the global automakers are utilizing encrypted software and component serialization to lock you out of your own property, turning physical hardware into expensive monthly subscriptions. On the other side, Wall Street private equity is consolidating the independent repair market, replacing honest mechanical assessments with algorithmic upselling and inferior parts. But just as the consumer feels completely cornered by these two massive corporate forces, there is a third, even more disruptive technological paradigm rapidly approaching the horizon. This looming transition does not care about selling you expensive parts, and it does not care about upselling you on preventative maintenance, because in this rapidly approaching ecosystem, you will not even be permitted to sit in the driver's seat. The transition from individual ownership to transportation as a service, driven by Level 4 and Level 5 autonomous vehicles, represents the absolute final nail in the coffin for the retail automotive repair sector. In the year 2026, we are no longer looking at a gradual shift. We are witnessing the aggressive deployment of massive, corporately owned robotaxi fleets in major metropolitan areas like Phoenix, San Francisco, and Austin. These vehicles lack steering wheels, brake pedals, and any physical interface for human control. They are geographically fenced, algorithmically routed, and entirely self-contained. But the most disruptive aspect of these autonomous fleets is not how they drive. It is how they are maintained. When a consumer no longer owns the vehicle, the entire consumer-facing repair industry instantly vaporizes. Consider the daily reality of a commuter named James living in the urban core of Phoenix, Arizona, in 2026. James does not possess a vehicle title, an auto insurance policy, or a relationship with a local mechanic. Instead, he pays a flat monthly subscription fee of $400 for unlimited access to a corporate autonomous fleet. One Tuesday morning, James summons a vehicle via his smartphone. A pristine pod-like electric vehicle arrives silently at his curb. As James steps inside and the vehicle begins navigating toward his office, a highly sensitive acoustic sensor mounted near the right rear wheel bearing detects a microscopic shift in vibrational frequency, indicating that the bearing is in the earliest stages of premature mechanical wear. The vehicle does not display a warning light on a dashboard because there is no dashboard, and there is certainly no human driver to alert. Instead, the vehicle's central processing unit instantly transmits a secure telemetry packet to the Fleet Operations Center. The cloud-based artificial intelligence analyzes the vibration signature, cross-references it with the operational history of thousands of identical vehicles, and confirms the bearing degradation. The system immediately calculates the optimal operational window. It determines that the bearing is safe for another 30 miles. The vehicle proceeds to seamlessly drop James off at his workplace, fulfilling its immediate contract. However, instead of entering a holding pattern to await the next passenger, the vehicle algorithmically removes itself from the active commercial dispatch grid. It autonomously navigates itself away from the city center, driving 20 miles to a massive, highly secured industrial complex located on the outskirts of the metropolitan area. This industrial complex is the grim, sterile future of automotive repair. It is a centralized fleet maintenance depot, completely closed off to the public and operating on a scale that mimics commercial aviation hubs. When the autonomous vehicle approaches the depot, it does not stop at a service desk to speak with an advisor. It rolls through an automated receiving tunnel equipped with ultra-high-definition optical scanners, thermal imaging cameras, and tread depth lasers. In the span of 30 seconds, the tunnel inspects the vehicle for any exterior cosmetic damage, maps the thermal signature of the high-voltage battery pack to ensure optimal thermal distribution, and measures the tire wear down to the millimeter. The vehicle is then automatically routed to a designated, specialized service bay. Imagine a technician named Elena working inside this depot. Elena is not a traditional mechanic. She holds a degree in mechatronics and optical engineering. Her workspace is not a grease-stained garage floor. It is a climate-controlled clean room with epoxy floors and anti-static grounding mats. Elena does not diagnose vehicles. The vehicles diagnose themselves and issue a precise, algorithmic work order before they even arrive in her bay. The vehicle autonomously positions itself over an automated robotic lift. Elena approaches the right rear wheel. Because these fleet vehicles are designed for absolute maximum uptime, they are engineered with highly modular components. Elena does not spend 2 hours pressing a bearing out of a rusted knuckle using a hydraulic press. She simply unbolts the entire pre-assembled wheel hub module, slides it out, and inserts a freshly calibrated, factory-certified module in its place. The entire physical repair takes 14 minutes. The true complexity of Elena's job lies in the optical and sensor arrays. The roof of the robotaxi houses a spinning LiDAR dome, utilizing pulsed laser light to create a continuous three-dimensional map of the surrounding environment. If a microscopic grain of sand scratches the protective lens of this LiDAR dome, the vehicle software will interpret the scratch as a permanent, ghostly obstacle blocking the road, paralyzing the autonomous navigation system. Elena must don specialized, lint-free gloves and utilize aerospace-grade solvents to clean and recalibrate these optics. She then connects a proprietary hardwired data uplink to the vehicle, allowing the corporate mainframe to run a simulated driving environment through the newly cleaned sensors, verifying their accuracy down to the nanometer before mathematically certifying the vehicle as safe for public transport. This centralized, corporately controlled maintenance ecosystem is an economic black hole for the traditional automotive aftermarket. Historical trends show that local economies thrive on the dispersed circulation of capital. When a local citizen owns a car, they buy parts from the neighborhood auto parts store, they buy tires from the local tire shop, and they pay labor rates to the independent mechanic down the street. The money stays within the community, but in the autonomous fleet paradigm, that localized supply chain is completely severed. The massive corporate fleet operators do not buy brake pads from the local retail store. They negotiate multi-million-dollar, direct from manufacturer contracts, shipping hundreds of thousands of parts directly to their regional depots at wholesale prices. The local auto parts distributors, the neighborhood tire shops, and the independent tool trucks are entirely starved of commercial volume. Furthermore, the legal liability landscape in 2026 mandates this absolute corporate control. In a world where the human is removed from the driving equation, the liability for any collision shifts entirely from individual driver error to corporate product liability and software negligence. If an autonomous vehicle causes a fatal accident, the resulting lawsuit will target the deepest pockets available, which belong to the fleet operator and the software developer. To defend against these multi-billion-dollar legal threats, fleet operators must maintain an unbroken, flawlessly documented chain of custody for every single repair, sensor calibration, and software update. They cannot and will not allow an uncertified, independent third-party mechanic to touch their vehicles, because one uncalibrated sensor could lead to a catastrophic legal disaster. The corporate firewall is absolute, built not just on encrypted software, but on the terrifying foundation of existential legal risk. As these autonomous fleets aggressively expand their operational territories, mapping new cities and undercutting the cost of traditional vehicle ownership, the American public is being slowly coerced into surrendering their keys. The convenience is undeniable, the safety metrics are continuously improving, and the monthly subscription cost is mathematically lower than a traditional car payment coupled with skyrocketing insurance premiums. But the hidden cost of this convenience is the complete forfeiture of mechanical autonomy and the total eradication of the localized automotive economy. The machines are driving themselves, they are fixing themselves, and they are enriching a select few corporate mega hubs while the traditional American garage is left to rust. However, this dystopian projection is not entirely uncontested. In the face of insurmountable technological monopolies, a highly organized, deeply motivated resistance is forming. As we prepare to conclude this masterclass, we must turn our attention to the survival strategies of the resilient few. We will examine the specific, highly lucrative niches that are completely immune to automation, the massive legislative battles poised to shatter the software monopolies, and the actionable steps you must take today to protect your assets, your career, and your right to own the machine in your driveway. The survival of the independent repair industry in 2026 does not look like the generalist neighborhood garage of the past. It looks remarkably like a high-tech surgical theater. Let us examine a deeply illustrative case study involving an automotive technician named Daniel operating in Portland, Oregon. 5 years ago, Daniel recognized the historical trends pointing toward the absolute eradication of the traditional general mechanic. Instead of fighting a losing battle against the corporately funded dealership networks and their proprietary scan tools, he executed a radical, highly calculated career pivot. Daniel completely stopped changing oil, replacing brake pads, and fixing transmissions. Instead, he invested $50,000 into specialized diagnostic oscilloscope equipment, commercial high-voltage safety certification, and advanced micro-soldering stations. Today, Daniel operates a highly lucrative, zero-emissions niche facility that focuses exclusively on diagnosing and repairing the proprietary printed circuit boards located inside electric vehicle inverters. When a complex structural battery pack or an integrated drive unit fails, the corporate dealership routinely quotes the customer $25,000 for a complete, sealed modular replacement. Daniel, however, has painstakingly reverse-engineered the logic board architecture. He can isolate the circuitry, identify the single burned-out capacitor that caused the catastrophic system failure, micro-solder a $3 replacement component under a specialized digital microscope, and successfully restore the entire vehicle to factory specifications for $2,000. The potential outcomes of this extreme hyper-specialization are economically staggering. Daniel is no longer competing with the corporate dealership. He is bypassing them entirely. He currently commands a 6-month waiting list because he offers a deeply technical, highly specialized service that algorithmic robots and quickly trained corporate gig workers simply cannot replicate. The future of independent automotive repair belongs exclusively to the diagnostic sniper, the elite technician who understands the binary source code and the printed circuit board fundamentally better than the manufacturer who originally designed it. But individual human ingenuity alone cannot permanently defeat a multi-billion-dollar corporate monopoly. The most critical battle for the future of American transportation is currently unfolding on the floor of the United States Congress and within highly polarized state legislatures across the country. We must deeply analyze the national right to repair movement as it operates in the year 2026. This is no longer just a fringe political movement championed by obscure consumer advocacy groups or niche hobbyists. It is a massive, highly mobilized and heavily funded coalition of independent agricultural farmers, independent mechanics, and everyday American vehicle owners who are actively demanding immediate federal intervention. The absolute core of this legislative battle revolves around a technological concept known as the Standardized Telematics Interface. Currently, automakers utilize cellular networks to beam your vehicle performance data directly to their private, encrypted cloud servers, positioning themselves as the absolute, undisputed gatekeepers of your diagnostic information. The proposed federal legislation aims to legally mandate that every single vehicle sold within the borders of the United States must be equipped with an open-source, standardized digital data port. This would allow a vehicle owner to securely and legally route their own real-time telematics data to any independent repair shop they personally choose, completely bypassing the corporate firewall. Imagine a scenario where your vehicle detects a microscopic voltage drop in a failing water pump, and instead of automatically scheduling an expensive, non-negotiable appointment at the dealership, the vehicle simultaneously beams that precise diagnostic code to 5 different independent garages in your zip code, effectively forcing them to competitively bid on your repair. This pending legislation threatens to instantly dismantle the lucrative captive market that global automakers have spent the last decade meticulously building. In aggressive response, corporate automotive lobbying groups are currently spending tens of millions of dollars attempting to kill these bills in committee, arguing vehemently that open diagnostic access fundamentally compromises national cybersecurity infrastructure and basic vehicle safety. The historical trends of these massive legal battles suggest that the ultimate legislative outcome will fundamentally dictate whether the average American middle-class family can actually afford to drive a vehicle in the next decade. So, how do you successfully navigate this highly predatory digital ecosystem today? How do you proactively protect your personal financial assets when the very machine you rely on to get to work is actively designed to extract your wealth? The first actionable step requires a radical fundamental shift in exactly how you evaluate a modern vehicle purchase. You must immediately stop looking exclusively at aesthetic design, horsepower ratings, and 0 to 60 acceleration times, and you must start forensically examining the digital user agreement. When you sit down in the finance office of a modern dealership in 2026, you are no longer just signing a standard automotive loan document. You are signing a sweeping, highly intrusive data privacy waiver. You must aggressively demand line item clarification on exactly what telemetry data the vehicle collects, which third-party data brokers the manufacturer sells that behavioral data to, and whether you possess the legal retained ability to opt out of over-the-air software updates without the manufacturer intentionally bricking your vehicle. Furthermore, we are currently witnessing a massive, unprecedented historical trend regarding the explosive financial appreciation of analog vehicles. There is a rapidly growing, highly educated segment of the American public actively seeking out well-maintained pre-2015 vehicles. These older analog cars, completely devoid of integrated cellular modems, centralized touchscreens, and over-the-air update capabilities, are now commanding a massive, almost illogical premium on the secondary market. Financial analysts refer to this specific phenomenon as the dumb car premium. Consumers are actively, deliberately paying more money for older, higher mileage vehicles simply because those specific vehicles cannot be remotely disabled by a bank, their physical hardware features cannot be locked behind monthly subscription paywalls, and their replacement salvage parts are not cryptographically married to the main engine control module. Purchasing a meticulously maintained, mechanically sound analog vehicle is no longer just a nostalgic aesthetic choice. It is a highly calculated, aggressive financial defense strategy against corporate surveillance and impenetrable software monopolies. For the aspiring automotive professional or the young student looking at the industry, the actionable advice is equally stark and uncompromising. If you are entering a vocational training program today with the specific intention of becoming a traditional, physical line mechanic, you are dedicating your life to studying a profession that will functionally cease to exist within your working lifetime. You must aggressively pivot your educational focus away from basic metallurgy and traditional combustion physics, and steer directly toward computer science, network cybersecurity, and high-voltage electrical engineering. You must train your mind to view the modern automobile not as a mechanical puzzle of gears and levers, but as a rolling, highly complex local area network that happens to possess a steering wheel. The elite technicians who will command secure, six-figure salaries in the coming decade are those specific individuals who can seamlessly perform packet-sniffing operations on a controller area network bus, those who can legally and safely decrypt advanced driver assistance modules without triggering a system lockdown, and those who deeply understand the complex, lethal thermal dynamics of lithium-ion cell degradation. You must intentionally build yourself into a hybrid professional, possessing the physical, tactile dexterity to safely navigate a high-voltage chassis, and the advanced digital fluency to rewrite a subnet mask on a corrupted gateway module. We have now extensively mapped the hidden battle lines of the American auto repair industry. We have methodically exposed the invisible, contextless algorithms quietly dictating your monthly insurance premiums, the aggressive corporate private equity consolidation of the trusted independent neighborhood garage, and the impenetrable software locks currently holding your private physical property hostage. You now possess a deeply comprehensive, heavily researched understanding of exactly how the traditional internal combustion engine is being systematically replaced by the subscription-based, remotely monitored rolling supercomputer. But this entire 10-part exhaustive masterclass has focused strictly on the terrestrial vehicles operating on the ground, navigating our current, rapidly crumbling two-dimensional highway infrastructure. What exactly happens when this exact same predatory software leasing model, this exact same corporately owned autonomous subscription framework, and these exact same catastrophic lithium-ion thermal runaway risks are aggressively applied to the rapidly approaching next frontier of mass public transit? As billions of dollars in venture capital aggressively pivot away from the asphalt and pour directly into the development of low-altitude, electric vertical takeoff and landing vehicles, the bitter war for hardware ownership is about to take to the skies. If you honestly thought that fighting for the right to repair a car in your driveway was a legal and logistical nightmare, wait until you discover exactly what the global tech giants are secretly planning for the personal unregulated airspace directly above your own home, and how a simple remote software glitch at 3,000 feet will completely redefine the concept of corporate liability forever.